Okay, hello everybody. This is the CUDAN Open Lab seminar on the November 25, 2024, which is the second keynote of 5 to sort of like not define, but sort of like circumscribe the emerging definition of what cultural data analytics can be. And today, with the greatest pleasure, we have Vittorio Loreto, who is a name that both physicists and linguists and computational social scientists, and now both is the wrong word, do know from a very long time. You have been a leader in the last 20 years, at least in this area. And we're talking, or we hear about new scenarios for inclusive and sustainable cities. What is quite interesting is that Vittorio is both a leader in academia and industry. So you have been with Sony for quite a while in, I think, Japan, in Paris, and now in Rome. And this is a rather interesting thing too. So I see Els Heinzelu in the audience here. So European countries have always been strong in complexity science. There have been different flavors in different countries. The Conference on Complex Systems, it has been the European Conference on Complex Systems, and now it's sort of like more general. And the cool thing is that this is now finally having a foothold in all different countries, and probably partially influenced by the Nobel Prize for Giorgio Parisi a couple of years ago. And also with machine learning, what we see today, the Nobel Prizes that were given out this year, they all sort of like have an undercurrent of complexity science and networks also, if you want to look closely. And Vittorio is really a leader also in Italy for that. In Italy in general is sort of something which people in other countries who are not in complexity science themselves may not have perceived is one of the leading countries. So I think Italy produces the largest number of outstanding complexity scientists, if I see this correctly. And Vittorio among that group has produced other people who sort of are excellent. So you are a significant or a substantial part of that. So we look forward to this with the greatest pleasure because it combines 3 things which we love a lot, which is cities, human culture, and also complexity science. So the stage is yours.
Thanks a lot, Max, for this lovely introduction. Thanks also, Mikhail, for taking care of all the bureaucracies behind this invitation. So I'm very happy to be here. I mean, actually, the first time I received the invitation, at some point I said, okay, I'll go to Tallinn. And then, and the message said, I read, this will be online. Okay, this is okay, but it would be nice to be with you today. So I decided to focus today on cities. As we said with Max earlier, so let's try to be interactive. So, stop me whenever you think it's important, to clarify something, or simply because you have curiosity, then we can take, a sidetrack for a while. We are not in a hurry, and so even if I don't finish, all my slides, I'm happy anyway. But the point will be trying to give you a flavor of what we're trying to do since a few years, actually, on the topic of cities. And this is mainly done, in collaboration with the 3 institutions you see marked here. My alma mater, which is Sapienza University. And then, as Max mentioned, I'm leading this Sony Computer Science Laboratories, first in Paris, and then now in Rome. Newborn, actually, since a couple of years here in Rome. And for those who don't know actually what CSL is, actually CSL is a sort of, I typically call it, a sort of free country within Sony. So of course, we are within the corporation, but still is the most academic division within a corporation you can imagine. So we are not forced to listen to the corporation, so to their needs, but of course, if they wish, they can listen to us. So that's the reason why, I got embarked in this sort of endeavor. And then I mentioned Centro Fermi here. Centro Fermi is a public research institution in Italy. And the reason why it's mentioned is because actually our lab in Rome is physically located within the Centro Fermi. And Centro Fermi is actually occupying the spaces of Enrico Fermi and his Ragazzi of Via Panisperna almost a century ago. It's physically the same place. We are very much honored as a physicist actually to be in this location. So going now in the heart of cities. Sure, this is not working now. Yes, now it's working. Of course, I mean, I don't need to tell you, I mean, why cities are important. Of course, there are numbers telling that 55, more or less, of the world population is actually now moving to urban areas in general, also including peri-urban areas or rural areas. And of course, I mean, cities from many different perspectives. You have seen, I mean, also a lot of scaling figures here. I mean, are basically, I mean, big centers for the economic development, but also for innovation and creativity for the world population. And of course, I mean, this comes with a package, and the package is all the pathologies. I mean, this big concentration of people can bring along, in particular, the impact on climate change, but also inequality, crime, gentrification. So you name it, all these features that we all know, but somehow we use, I mean, to consider them as a sort of natural for cities. And probably the pandemics and the COVID-19 crisis made, I mean, even more clear the need for a redesign of cities. Okay, we always thought that cities are the way they are. I mean, we cannot change them, but perhaps, I mean, during COVID, we learned that there is another way in which we can actually live within cities, not necessarily more pleasant, but for sure, I mean, we can change something. So this is, I mean, I hope could be a trigger for a change. And what is interesting is I like to look at cities like complex evolving ecosystems, because we have many different layers, many different elements connected, and the human species are, of course, is one important element. We tend to believe that we are the only intelligent species within a city in general on the planet, but we are not. There are many other animal cities or plant species. And, but of course, I mean, the built environment and the natural world, I mean, is part of this ecosystem. And whatever is happening in cities actually has to go through all these different layers and elements. And what is interesting, again, about these elements, I mean, the reason why we say that it is complex is because there are complex interactions. So there are complex feedback loops and cause and effect interactions that are very difficult to single out, I mean, and to detail, much in the same way in which is very difficult to, let's say, single out all the possible interactions in a natural ecosystem. So, I mean, what happens is typically you tend to cure a specific aspect of the city, you make a specific intervention, and you hope, I mean, this will have an intended outcome, but then, of course, perhaps it can have the intended outcome plus a certain number of additional outcomes, perhaps unintended and not specifically pleasant. In order to understand, I mean, this complexity, a few years back, we actually devised an experiment. And this was an interactive experiment. I hope, I mean, the video is working for you. I'll show you the video, then we'll discuss the outcome of this. Yeah, perhaps I can stop here at some point. So this was an interactive experiment when people were supposed to build a city using Lego bricks. At that time, actually, we had a collaboration with the Lego Foundation. And of course, I mean, the building of the city was not so simple, because actually you could see actually there were monitors in front of the player, and the monitors were actually displaying the status of the city. So how good is the city, the present city people were building. And behind this, actually, there was a point that there were cameras and sensors, and sensors were actually computing the amount of bricks of a given color, also in 3D, because they were basically infrared cameras. So basically, all these elements, like the amount of color of different amount of bricks of different colors, were basically the input for a mathematical model, which of course was underneath. And through this mathematical model, there was a feedback given to players. So basically, players were building the city and then looking at the feedback, and then they tried to change back in order to improve, I mean, all the quantities. And of course, I mean, what it was not clear that is behind. So this was an example of the kind of feedback. On the left, actually, there were the input parameters. So basically, there were 5 colors, okay, recognized by the cameras. And through these 5 colors, you are actually fixing the population, the jobs in different sectors, but also the amount of green areas. But then the model was actually giving it a feedback in terms of other quantities that you see on the right, like the quality of life, the employment, fraction of highly educated people, the salaries, the Gini coefficient for inequality, so a certain number of other socio-economic factors. And of course, I mean, you don't have a knob, you don't have a Lego brick for the quality of life. You can only change, I mean, the Lego bricks on the left. You see, I mean, it's not obvious. I mean, if I ask you, I mean, this was a typical challenge or a mission for people. I mean, can you increase the quality of life in this city? It is not obvious, I mean, to do this because, I mean, you don't know, I mean, which knob, I mean, or which element on the left can actually be responsible for the quality of life on the right. And actually behind this, I tend not to show formulas, but this is probably one of the only ones. I mean, behind this, there was a mathematical model, which is based on the Hamiltonian. So the Hamiltonian in general in physics is used to describe, I mean, the interactions among a certain number of elements. And in this case, you have a Hamiltonian in which the first term, or the one with the J alpha beta, is a typical, let's say, Gaussian term, I mean, very regular term for interactions of binary interactions. But what is interesting is in order to reproduce the empirical data, actually we had data from cities in Italy, France, and UK. In order to reproduce those data, you had to introduce, actually we had to introduce also 3 points interactions, which is interesting, right? I mean, totally non-linear elements, which means that typically this is a situation in which you change alpha, okay, and you hope, I mean, to change beta, but also you change gamma in this situation. So this is not intended, and it's not really controllable. So basically this model was used, I mean, much in the same way in which now you would use ChatGPT. Oh, there is a question from Mike.
Yeah, basically I wanted to ask what exactly are the parameters X alpha and beta, etc. So what are the variables?
So the variables are the ones that you see here, for instance. So housing population, jobs in private sectors, job in public sector, the left and right, basically socioeconomic factors. And
yeah, so they are non-local, they are just overall characteristics of the city as a whole.
Overall characteristic of the city, yes.
Okay.
Like one of the possible extensions could be going local to the different neighborhoods within a city, but at this level, actually, this was a global one, actually. So in this sense, actually, the actual structure of the city people were building was not meaningful, okay? If I put them in all the orange in one place or totally scattered would actually be the same situation. But of course, I mean, for people it's meaningful, I mean, the actual location of a green areas. So and the coupling parameter is J, so J alpha beta or J alpha beta gamma were actually inferred through a maximum entropy process based on real data from the 3 countries I mentioned above. And it's interesting because, I mean, while people play, of course, they don't know anything about the underlying model, but actually they keep playing and they keep learning, actually. So this is the fraction of victories. I mean, victories means, I mean, you have a mission and you have to accomplish a specific mission. This is increasing over the number of matches you play. We could also define a sort of level of complexity of difficulty, if you wish, of the specific challenge or task, depending on how small, I mean, is the area in the phase space you have to reach with your moves. Okay. The smallest is this area, I mean, the more complex is the task. What difficult, I mean, is to reach this goal. And you see, unsurprisingly, actually, the success probability decreases with the complexity, which means that somehow people are learning something, okay, also learning the complexity of the interactions, even without knowing anything about the actual mathematical structure of it. So this is the global structure, basically. So you build, and then there is an input for the mathematical model. The model gives you a feedback, and then you keep building, and so on and so forth. And of course, I mean, this stayed at the level of a sort of game, okay? It's not concrete enough, I mean, to do planning, but in principle, I mean, this kind of modeling scheme, especially now with the computational tools that we have may actually turn out in something usable at the local scale. So this was just to tell you, I mean, about the overall complexity of cities and the level of interconnections of all the different elements. So at CSL, but also at Sapienza, we look at cities also from different points of view and different scales. Of course, cities have many different possible scales. So the macro scale would be the scale I just showed you, I mean, in which a city is just one point in a big phase space. And of course, I mean, you can imagine that you can use, I mean, the model just described in order to see, okay, for instance, my city is a city A, okay? It's not very good. But then I have a city B somewhere. It could be, for instance, in Europe, could be Vienna, or I mean, some of the cities in Australia, right? And I want to improve my city in order to be closer, I mean, at least better to better cities like Vienna or some cities in Australia. Of course, I mean, the point is, how do you move, I mean, in this complex phase space in order to get your city close to, I mean, another good city? Of course, you cannot turn, I mean, for instance, Rome into Vienna, because, I mean, you have to find, I mean, the Rome way to be good as Vienna. But still, you can be in the same area in which Vienna is good and still find, I mean, a good solution for Rome. This would be the macro situation. Then there is what I call the meso situation, which is the situation in which you look at the actual map of cities. You see, I mean, the actual differences from one place to another. And actually, I'll mostly focus on this area. Then we have also a small activity on the micro scale. So the micro scale is what I call the smart city, even though actually I don't like this term smart city, because it seems that through technology, you can actually improve cities. And that would be the only ingredient for a good solution. I don't believe it, but still we do something about cameras and try to infer some local parameters from cameras and sensors. So let me focus on the meso scale. And of course, here there are tons of questions. I will not be able to address all of them, but I like a lot, I mean, the point of urban inequalities, because of course, I mean, cities nowadays are sustainable simply because they are there. Of course, I mean, they keep thriving in a way. So if we focus on Rome, I mean, Rome has 27, almost 28 centuries of life continuously. And of course, this is sustainable, right? By definition, this is sustainable, but it's not something we always like. And I guess we don't like because, I mean, we also care for the quality of life and inequalities. So inequality is one element. Also, then there is all the point about climate change and the green transition, which is interesting. And of course, cities could be a big motor for those transitions. I mean, not to forget, of course, sustainable technology that can actually help, I mean, cities in order to be even more sustainable from many different perspectives. One key, let's say, format I like to discuss is this on the proximity-based cities. Okay, you probably heard about the 15-minute city. Okay, this is a notion which is very old, actually. I mean, the idea of proximity-based cities is even older than 15 minutes. And 15-minute city was actually heralded by Carlos Moreno in Paris. And the general idea of these proximity-based cities is a sort of change of paradigm from a cities in which you have to reach as fast as possible all the possible destinations to a city in which all the needed and important services should be reachable by walking or biking within 15 minutes. Then whether it's 15 or 20, I mean, doesn't matter. But the point is to have all the essential services within proximity. This is a very big change from the present situation, actually. So present cities are actually based on speed. So they need to move as fast as possible from A to B with all the pathologies that we all know, I mean, in big cities. You probably know, I mean, this Marchetti invariant or Marchetti constant. So this is a paper from 30 years ago, actually 1994. This picture actually is a picture in which you look at all the transportation modes over the years. Okay, you see from 800 to 2000, 1800 to 2000. So basically the key point is the transportation systems improved, I mean, improved the speed, but actually this didn't decrease, I mean, the distance reached by people in their commuting. Okay, so somehow it's like if people, I mean, on the anthropological point of view, we're always committed to the same commuting time, then of course I can move, faster. Probably my commuting time will be a longer and longer distances. Okay, and actually I cannot speak for this because I've been commuting with Paris on a weekly basis for 6 years. So I'm not actually the paradigm of a green person from this perspective. But this is the way in which cities have been evolving over the years. So somehow, the idea of the 15-minute city is totally different. The idea is, okay, probably we don't need to move, for everything. Probably we need to move for something very important, but not for everyday basic services. So what we did in this area was, of course, there's been a lot of let's say, real-world implementation of the 15-minute city, okay? Paris is one example. Barcelona is probably the most famous example too, Milan, but there are many other cities which in a way or another are trying to implement this idea. But actually, when I looked at this, actually, I was asking, okay, but how much are present cities close to this idea of the 15-minute city? So we came up with this platform where you can freely explore, this platform. I checked this morning that Tallinn is included, so you can actually explore also Tallinn in this platform. And a typical situation for each city that you would see is something like this. So this is Rome, okay? And the color code is as follows, actually. Blue areas are areas. So we basically divide all the city in hexagons. Okay, the size of each hexagon is more or less 200 meters, so very small. Highly fine range. And the blue colors are color in which the accessibility time, which means the average time to access all the needed services, is below 15 minutes. All the red colors are above 15 minutes, and the whitish colors are basically the interface. Right, 15 minutes. And you can actually notice one important point here in Rome. First, the city center is very blue, okay? But then as you go further, towards the peripheries, you turn into white and then eventually red. Then an interesting point is actually the heights of these bars. So the height of this bar is actually the local population in the area. So in the ideal case, you would need, blue, very high bars, okay, and red, very low bars. So if there is no population, okay, it's okay. If the accessibility is not very high, okay. If a population is high, actually, you need a very good accessibility by walking or biking. In this case, then we would include transportation systems in a second. And you see, mostly, of course, there is a correlation between the population and the accessibility. But again, this is mostly in the center. But if you go in the outskirts, you would see that there are a lot of high bars with colors which are reddish or whitish. So this is again, a map of Rome. So without the population, you see, there is a sort of radial structure, which means that if you look at the fractional population in a sort of 15 minutes condition, this would not be definitely 100%, non-zero, but definitely not 100%. If you click on one specific point of the city, you can actually look at the details of this specific area. So in particular, you can look at the 9 or 10 different services included in the basket, original basket, proposed by Carlos Moreno for the 15-minute city. And you see, for instance, learning, supplies, eating, moving, cultural activities. You see the red circle is 15 minutes, and then the green is by bike, and the yellow contour is by food. And you see, depending on the specific category, you can be within 15 minutes or above 15 minutes. Okay, so each specific spot can actually be classified depending on the specific category of services. And you can explore a bit this. You can play a bit with this. So these are a few examples just to show you, the differences among cities. You can notice, for instance, that Paris, is quite good. It's quite blue from this perspective, as compared to Atlanta on the other end. Atlanta already the downtime, could be blue, but the rest is reddish. And this is no surprise at all, right? we'll discuss more about this, about why Atlanta, but also, other areas. For instance, in Rome, you see the city center is quite good, but then if you go in the outskirts, the situation gets worse and worse. So this is a visualization prepared by Nature a few weeks back in order to show, the wild differences from cities, classified for different continents. So you see Europe, is basically leading this sort of ranking for this, and a few cities also in other continents. But if you go, for instance, for North America, most of the cities are basically red. And this is by design, by the way in which cities have been growing over the past years. So there is a wide latitude of differences here. I'm not sure I can see all the questions if they are, but in case, Max, tell me if there are other questions.
Yeah. So if you want to ask a question, please, like anybody in the audience, just either raise your hand. Online, there is this function. We will monitor one of the screens. Can you see them, Mike? Everybody? Okay. And then the other option is to just speak up, which is also perfectly fine.
Yes. Just stop me. Yes.
Cool.
It's nice.
I've noted my questions, and we might probably go back. This is super fascinating, actually.
Okay, I continue. Sorry, I don't know what it is. I clicked on the wrong. Okay, now coming to inequalities. This is one of the key plot. So if you go on the left, on the x-axis, you have the proximity time, okay? And on the y-axis, you have the fraction of population, okay, below that time, okay? So below 15 minutes in a way. So you see, if you take the intercept between 15 minutes, so the vertical gray line, and each curve, for different cities, you would see the fraction of population living in a 15 minutes condition. For instance, the one highlighted is Paris. So you see Paris is very close to 95% of the population, which is quite good. But if you look for Atlanta, for instance, which will be the orange one, you see the intercept is basically less than 10%, okay? And now you can actually transfer all these intersections to the right plot. So the right plot actually is the proximity time at the level of the city, okay? So the average one, and the F15 is the fraction of population living in a 15 minutes condition. And then you see basically there is a sort of pattern, from top left to right down, okay? So top left are basically very good cities with a very small proximity time, a very high fraction of the population living in those conditions. And then down right, basically there are cities in which the actual proximity time is very high, and correspondingly also the fraction of population living in those conditions is very low. But also there are huge fluctuations. So for instance, if you take a horizontal line on the right plot, let me show you in this way, basically the colors now are the Gini coefficient. So basically the larger is the proximity time, even though with the same population fraction living between 15 minutes, and the higher is the Gini coefficient. So even within actually the same bracket for fractional population, you could have wild fluctuations from one city to another. So if you wish, when we looked at this plot, the question was, okay, is there any way in which we can improve the situation? Improve means, take any of these points, which represent, each of the points is one city, and try to move upward and leftward in some way through some kind of intervention. And actually, we conceived an intervention, and the intervention seems very weird, but actually, if you think carefully, it's not. So the point is this, actually, the point is the accessibility of services. So services in the databases are basically marked as POI, so point of interest. They can go from a theater, a cinema, a restaurant, a bar, or an hospital, or a stadium, any point of interest on the map. And so the point is, eventually, this is the original distribution of point of interest in an area like Rome, okay? And in this situation, this is the real city now, 71% the population is actually residing in a 15 minutes area. So the point is, can we actually not move people, but move the services, so the POIs, so relocate the POIs depending on the population in a way to improve the fraction of the population living within 15 minutes, okay? So, and this animation is actually showing the outcome of this simulation. So you see there is a sort of migration of POIs and services, and the final distribution is very close, I mean, to the actual distribution of population. You see, eventually you will get to 90% of the population living in those conditions. This is a simulation in which we keep the same number of services or POIs in the city, and we just relocate them, okay? Then if you think that this is difficult, I mean, you can think that the average age of a bar or a restaurant is typically a few years, 2 or 3 years. So relocating these objects is not very difficult. Of course, I mean, relocating an hospital or a stadium is difficult, right? Okay, but we'll get to this in a second. But for most essential services like groceries, I mean, the turnover of this is very fast. This is another experiment in which we start with no POIs, and we just add POIs to the city depending on the needs of the population. And you see, you start from 0%, a little by little, you end up to a distribution of POIs, which is very close to the ending point of the previous simulations, in which we started with a certain number of POIs and then we relocate them. If you look at the map before, I mean, the map in which blue means within 15 minutes and red means about 15 minutes. Also, in this case, you can see how the map is changing over time. And I show this, I mean, and I wish you to appreciate one element. The first one is the city center is not destroyed, I mean, in its good accessibility by this relocation. So city centers are so overwhelmingly filled with POIs that even if you remove a few POIs from the city centers, nothing will basically change. But on the other hand, we are actually improving, so making more blue a lot of peripheral areas in the city.
May I ask a question?
Yes.
Yes, can you go back? So Rome is really special because it has these areas which are sort of top-down defined, like Tiburtina, where you get basically infrastructure, street network, even the houses look sort of always the same, so they're regulated. And there's other places like on the other end, like Matteo Battistini, where basically the only thing that was ever put there was a water pipe, and that probably was also illegal. And then you have this sort of emergent growth. And the question is, like, which of these places actually would more follow your sort of emergent sort of like distribution of services? Because obviously, if it's not top-down regulated or endorsed, then certain services will never turn up. While if it's all top-down regulated, certain sort of like wild growth of like nice businesses that are in competition with each other may not turn up. So how do you deal, in other words, more simple, how do you deal with the natural heterogeneity of an ecocosmos that has 3.5 million people and geography and whatever?
Yeah, I mean, but in this way, actually, you're actually moving from this sort of what-if experiment to actual policy, okay? Because the point is, who has to go first in this situation? Who has to move first? I mean, also consider that the typical strategy now for, especially for commercial activities, is to cluster them, okay? Because we want to be in the same area, and the area is attracting people, for instance, overnight, and then you want all the restaurants and bars in the same area. But perhaps there are 2 or 3 points in the city like this, which is totally the opposite of what would be the real proximity-based city. So, I mean, I don't have an answer to who's to go first in this situation, but I guess this is a sort of feedback loop, right? I mean, once you move and you move in a sort of coordinated way, I mean, which of course, I mean, has to be not, I mean, let's say decided top-down, or at least not entirely top-down. Of course, it has to be accompanied by, I mean, a good communication to show, I mean, what could be the potential of this movement, also in terms of the commercial activities. Because, I mean, for once, I mean, if you start closing, I mean, the city centers to cars, and we'll get to this in a while, then also commercial activities will suffer, which is a typical situation in many city centers. So I'm not sure, I mean, I replied to your question because I don't have a real answer to who has to go first And of course, the heterogeneity is very strong, and presumably, so the algorithm, what it's doing is actually relocating based on the local density, local population density. And so, I mean, local communities could actually push for it. But in many cases, I guess, would be almost obvious what is the solution, because in many cases, you don't have services at all, okay? You have to move very, very far in order to get the first services. Okay, this is, for instance, this example in Rome in which you are actually improving, I mean, the situation here and there. Again, so this is another way to show, I mean, the outcome of these simulations. So on the left, you have basically the average number of POIs. So the average density of POIs locally before the intervention and after the intervention. You see that after the intervention, this is basically more uniform, more whitish with respect to the original one. And so going back to the picture of before, in which I was actually asking whether we can improve the situation in order to go from cities which are, I mean, down right to cities which are typically top left, you see this is the outcome of this situation, the simulation for a few cities. And you see there is this trend of moving, I mean, upward and leftward, except for situations in which it is very tough, like Atlanta. No, I'm sorry, I mean, for the citizen of Atlanta, I mean, there's a typical case we take, I mean, to illustrate this. There are many other cities like this in the US, but I guess the point is really the philosophy through which these cities have been growing in the past decades. Okay, we published this paper recently on Nature Cities, it's just bragging. But so the main conclusion we took from this is it's not impossible to make peripheries better, okay? And while doing this, I mean, not impacting the city center. So actually disrupting the good accessibility of city centers while you're actually improving peripheries. It's a sort of improved Robin Hood scheme. Some of the present cities, mostly in Europe, are very close to the optimal, but some of them are very, very far. Okay? And the point is this for cities in which, or areas in the cities in which the situation is very far from optimal, this is typically due to the fact that the density, the population density locally is very low, okay? And so it would be really economically unsustainable to fill these areas which are poorly populated with a lot of services. Also, economically probably would be a sort of suicide. So I guess our conclusion from this was the 15-minute city, that in general, the idea of the proximity-based cities is just one part of the ingredients we need at this stage, but probably we need a larger generalized scheme for many reasons. Okay, but before getting to many reasons, let me first ask, I mean, whether we really like, I mean, 15-minute cities, because, you know, you can say they are good because, okay, you need to be able to say that they are good because of something, okay? And so one of the first questions is whether these proximity-based cities are actually greener in terms of less CO2 emissions on a global scale. I show you this, this picture. And on the right, you see basically on the x-axis, the fraction of population living within 15 minutes. On the y-axis, the CO2 per capita emitted in tons. You see there is a decreasing trend. So the larger is the fraction of the population living in proximity-based cities or 15 minutes conditions, the lower are the emissions in terms of CO2, okay? Which is a very interesting outcome. Still, there are huge fluctuations. So basically, if you fix on a vertical line like 60 or 70%, you would see that there are huge fluctuations in terms of CO2 emissions. This is at the global scale for a city, but you would see this also share data also on the local scale within a specific city. This is one specific case within a city for Tokyo, okay? And you see we divided Tokyo into a sort of square lattice, and there is a very good correlation between the proximity time and the CO2 per capita. So in this case, the proximity time means that the good situation is on the left, so low proximity time, which means good proximity, good accessibility for services in proximity, and lower CO2 emissions. But if you look at this, I mean, in general, you see that actually there is a strong impact of the city areas, okay? So what is important is not only the fraction of population living within 15 minutes or the proximity time. If you look at the inset, basically you would see that all the red cities, which are the cities, I mean, with largest areas, are also the ones, I mean, emitting more. So basically, larger is a city, and larger are the emissions per capita. Of course, I mean, larger is a city, larger are the emissions overall, but this is per capita in terms of CO2 per capita. So I guess the message, I mean, the take-home message from this is, in general, one can say that proximity is very good also for emissions. With, I mean, a caveat depending on the city area. This, of course, is a caveat for megalopolis. So, I mean, the question is, I mean, can we happy with this idea of the proximity-based cities? Actually, we are not. Okay, we are not for many reasons. So the first one is, okay, the example I always give is the following. Suppose you have a perfect 15-minute city, which means, I mean, from any possible location in the city, you can access all the essential services in 15 minutes. Okay, this is just a utopistic or ideal city, okay? But then you have one area of the city, I mean, with very high quality services, and another area with very low quality services. This is not a city we like, right? So you can be perfectly 15 minutes, but this is not something we like because there will be inequalities in the values of services provided. The other point is the question of landmarks. So you can say, okay, I want to access my grocery store, I mean, in 15 minutes from any possible location in the city. But you cannot pretend to access Coliseum or a big stadium or a big hospital in 15 minutes from any possible right location in the city. So this is something, I mean, proximity cannot solve. You know, there is a sort of an interplay here, actually. So interplay of different scales. So from left to right here, actually, you have different scales. So what we call the 1-minute city, 15-minute city, 30-minute, 60-minute cities. And if you increase, I mean, the scale, okay, you increase also the size of the infrastructure built, right? In 60 minutes, basically, you have stadium, cathedral, subway, regional grid, while 1 minute could be a shared garden of your neighborhood or a shrine or bikes, sharing scooter, microgrid, I mean, this kind of stuff. And if you sweep through all these scales, basically there is an interplay between what we call the participation on the one hand and the representation. Participation means local communities organizing themselves in order to create some local infrastructure, okay? And the community garden, I mean, is easy to do, I mean, at the community level, okay? Of course, I mean, if you want to, for instance, make a specific street pedestrian, this is not local anymore, because, I mean, making a street pedestrian implying actually redesigning the global street network. So this has to be done at a larger scale. But of course, if you want to construct a stadium, this cannot be done by a community. So this is basically transitioning towards representation, which means, I mean, policymakers and stakeholders who actually take care of this, and you actually ask them to represent you for those kind of decisions. So this somehow it's opening, I mean, a huge area of decision-making at the social level for this kind of initiatives. Now, I mean, I wanted to go back to the idea that we have to go beyond the pure proximity, only using, let's say, muscular mobility, like walking or biking, okay? We also use transportation systems, right? Okay. And so I wanted to show you this other platform we constructed actually before the 15 minutes platform. It's called CityCron. In this case, I mean, the key point is accessibility through public transportation. So there are less cities in this case because we need to have all the schedule of the timetables of the transportation systems. So it takes longer. But this platform is basically for two purposes. On the one hand, I mean, the assessment of the present, so how accessible are specific areas through transportation systems in the present, so the real situation. And on the other hand, on the right, you see what-if scenarios, which means, I mean, what would happen to the accessibility if I take these specific actions? So we have a platform in which you can play, for instance, a specific action you can take for the what-if scenarios would be adding a new metro line, and then adding a new metro line to the actual timetable. Let's see whether this is carefully planned in order to improve accessibilities, not only along the new metro line, but also through a careful and suitable interconnection with other infrastructure, also very far from the new infrastructure. For instance, the basic point here is to compute the isochrones, which will be, if you click on a specific point here, for instance, is Paris, you want to know, I mean, how far you can go with transportation system, multimodal, of course, I mean, which will be working, taking the metro, then working again, taking a bus, a tram, etc., to reach any possible other location in the city. You see, you have a sort of radial structure by definition, but the structure of the ISO lines is not circles, which will be a perfect isochron, okay, but they're very regular depending on the local conditions. And based on this, based on the isochrons, then we put together all the information from all the possible locations in the city, and we compile this map, which we call the velocity score. So now redder is the color, okay, and higher is the velocity to reach the specific point in the map. So again, the city center is highly accessible through public transportation, but then if you go towards the outskirts, I mean, the situation gets worse. In this situation, probably this gets worse in Paris when you are at 20 or 30 kilometers from the city center. So you can actually recognize, I mean, the sort of discrete structure of the metro lines and the train lines, right? Because you have sort of red or reddish spot, also very, very far in the middle of the blue. From this perspective, if you look at the timetable over the day, you have a sort of breathing city, because the accessibility is changing over time depending on the moment of the day, because of course, I mean, overnight there are less transportation systems, and then on the peak hours, they're trying to adapt to the needs and so on and so forth. So you see there is an interplay between the way in which we plan infrastructure and the actual needs of people, which would be a key point for the end, because we typically don't know the actual needs and, let's say, ambitions of citizens. So basically, the first step towards going beyond the 15-minute city is what we call the opportunity city. So somehow the key point here is, okay, it would be important to have all the essential services within reach, walking or biking. But if not, if this is not possible, because I mean, I live, I don't know, 50 kilometers or 30 kilometers from the Coliseum, I still should have the right, I mean, to reach the Coliseum in a reasonable time. So the transportation systems in this way should be good enough. So another point to look at the city is trying to get rid of the let's say, dictatorship of time. So we don't want to maximize time anymore. And let's say we want to maximize for each location in the city the number of opportunities seizable by any sort of transportation system, whether walking, biking, or train, metro, buses, whatever. And this is one of the first maps we compiled for Rome. Again, I mean, if you go towards yellow, this means that the number of opportunities is very high. You see of the order of 3,000 in the city center. And of course, I mean, this decreases, I mean, not in an homogeneous way, but this decreases with the distance from the city center. So again, this is a map of inequalities in the city, because the number of opportunities you can see is, if you're in the center, very much higher than any other point in the peripheries. And another interesting point is, if I now map the structure of the metro lines in Rome, which are not very many, actually, 3 lines, 3.5, okay, you see the number of opportunities is highly correlated with the path of the metro lines. So this is just the beginning of something. The last point to be discussed is public versus private, because of course, I mean, people move also with private cars. And And of course, I mean, one interesting point will be trying to assess whether you really need a car or not. One way to do this is actually to look at the number of opportunities, which will be POIs, reachable through public transportation, okay, with a combination with, of course, I mean, walking or biking, and the number of opportunities reached or seizable by private cars. So, for instance, this is the situation for Paris. So the colors now, I mean, the more you are yellow, the higher is the number of opportunities seizable by public transportation on the left and private car on the right. Okay, so this is a good representation. And now we want to put together these two elements. So this is Rome, by the way. You can already see the difference by car. I mean, the number of opportunities seizable, I mean, is much higher than with public transportation, except for the city center, which, of course, I mean, with closures, I mean, another infrastructure, perhaps it's not possible to move by car. So the point is to put together these two elements, and we combine these elements in what we call the car dependency index, which, as you can see, is basically the difference between the number of opportunities reachable by car and public transportation suitably normalized. Now, one important point, and this is key, I mean, for this calculation, but also for the city cron that you saw before, people do not accept all possible trips of any length in time, okay? So the typical way to model this is to say that there is a kernel function, and I basically accept to embark in a specific trip with the probability that depends on the length of the trip. Because typically these functions are best approximations is exponential. So basically, whenever I compute, I mean, the average time to reach any other possible element in the city or location in the city, I basically make a convolution with this distribution. So I mean, very long trips are basically cut exponentially, because otherwise I could basically consider also trips to, I don't know, the other part of the planet as a potential, trip. And now if you put together all these elements, you can now compile maps which are much more informative than before, which will be the car dependency index. So now red means that you're very dependent on cars, okay? While blue means you do not depend on cars. So probably you don't need the car because you have alternative options to reach POIs. As you can see in Rome, the blue part is very, very tiny, it's very, very small. There is a whitish part, I mean, along the metro lines. But in Paris, most of the city center, so within the Boulevard Périphérique, is basically blue, okay? And then if you go, of course, in the outskirts, I mean, the need for cars, I mean, it gets higher and higher. Also, I mean, if you go farther away. Of course, this is not, okay, it's an interesting index. The question is how you can use this index. For instance, in Paris, now there is a sort of war to cars. So 30 kilometers per hour, getting a lot of street pedestrian makes, I mean, the circulation in Paris almost impossible. Probably you don't need a car, and probably you don't want to have a car in Paris because it's a night unless you want to go out. And this is somehow reflected, I mean, in this scheme, actually. So you don't need a car in Paris, but nor in Tokyo or many other Manhattan. I mean, you don't need a car, it would be a nightmare. And most of the POIs you need are basically reachable by other tools. If you do this for Manhattan will be, of course, I mean, very 15 minutes, but the rest of Queens, New Jersey, Brooklyn are very, are not 15 minutes at all.
May I ask a question?
Please.
Yeah, if you can go back to this other picture. So Rome is this, you know, this was an artwork at the Villa Medici a while ago where somebody put up white Vespa scooters like jumping horses and called it the horse of the 20th century. And everybody who lives in Rome knows that sort of the city is full of these motorini, Vespas,
yes,
small motorcycles and stuff like that, which now have been joined by these electrical scooters, which a lot of the red part here, you know, if you give that talk in Davos or, you know, anywhere else where people are not so familiar with the city, may think, oh, there is like a car collapse like in Los Angeles, which is not true, because people sit on these sort of like one-person transportation devices, which are way smaller, allow for a larger density, may still be stinky and produce CO2. But would it make sense to actually, instead of like calling this car dependency, calling it sort of like collective transportation versus individual transportation, which may change the whole, like, you know, for example, individual transportation has the advantage that you could still go during a pandemic, for example, right?
Precisely. Yeah, it would make a lot of sense, actually. This is not yet included here. I mean, so we include a lot of things. For instance, we include time for parking, which will be, of course, I mean, almost, I mean, entirely reduced. I mean, if you have a scooter, okay. But also circulation time, okay, traffic time, which will be reduced in this case. But still, we have to run this simulation. But this is a very good idea, very good suggestion. So individual versus collective dependency. I'm pretty sure, I mean, the situation will change drastically. Yes. And yeah, these are other pictures from other cities. And you see, I mean, Milan is not so bad. I mean, Paris, I mean, is better. Vienna, of course, I mean, there is a city center for this. So we can do this for many different cities. And also in this case, you see that there is a very heterogeneity between different cities. So zero value for this dependency will be the break-even, right? Okay, be the situation in which you would actually access the same number of opportunities either by car or by public transportation, including also parking time and everything. But I suspect that also the break-even people perhaps would prefer, I mean, the car, because they can still, I mean, have a more comfortable trip with respect to public transportation. So now questions, okay. So there's a lot of questions, more than answers here. And I guess, I mean, the first point is we need to go beyond the idea of one-fits-all solution, okay? You know, we have seen a lot of scaling for cities, which is remarkable, okay? But I think scaling, I mean, is very useful, let's say, once you know already the situation and then you look at what happened, okay? But it cannot be used in a sort of predictive way. And you cannot pretend that the solution implemented in city A can be the same for city B. Sometimes not even in different areas of the same city. So one has to be really, really flexible. And for this, actually, the idea of the 15-minute city is very, very good in general, also to reduce emissions. But this works only for very compact areas, so areas in which the density is very high. I would say in general, it would be interesting to go beyond the pure proximity and try to include somehow the number of opportunities and the value of those opportunities in the equation, try to optimize for this, which actually would try to optimize for the number of, let's say, opportunities people could actually seize in the city. It's very important to have good modeling schemes because this is the only way in which you can define scenarios, so what-if scenarios, and say, okay, if you do this, the most likely outcome of this measure will be this one. This somehow is connected to the big emphasis now on digital twins. Of course, digital twins is a fancy name now, okay? We've been running simulations for decades, now they're called digital twins, but the point of digital twins is they're never the perfect replica of the city. So there is always some element you're not considering in there. So I guess for local interventions could still be good, also for global intervention, but that you do not control for additional, I mean, side effects like we saw, I mean, in the original model with the Lego city. And then two more points. I mean, the first one is about the smart city. So again, there is a strong emphasis in saying that, I mean, through technology, cities will magically become better. Okay, I don't believe it. I think, I mean, all this technology could be an enabler for us, I mean, to implement new solutions. but definitely it's not the best solution or the whole point. And it is connected to the idea that no solution can actually be enforced, I mean, in a city, unless citizens can actually be in sync with those solutions. So that's why, I guess, also for the scientific community, which is actually always looking for new data in order to make models and to make predictions. But you know, I mean, gathering reliable data also on people needs, for instance, is not so easy because I mean it's so difficult to me to understand what are the needs. I mean, and what people do, I mean, doesn't mean that they actually need this. I mean, what people do could be connected to their surviving strategy in that situation, right? Okay, but what they would do if they had the opportunity to do something else probably is different. Okay, so I guess participation could be an important element for the design of the cities of the future. I will probably stop here because I spoke even more than 40 minutes, and the floor is yours now for questions, shooting, criticism. Thanks a lot to everyone for listening.
Yeah, thank you very much. I'm not going to remove the slides fully and make them smaller and make everybody visible.
Yes.
So, which everybody can do in their own Zoom. It's just like for the recording later. So yeah, thank you very much. This was amazing. And thank you very much for adding my favorite city, Rome, which I know a little bit.
Yes, you know very much.
So this is very cool as an example. And so maybe we should just rotate it out to the audience. I have noted down plenty of questions, but I'm pretty sure other people have questions too. So anybody who wants to start? Yes.
Yeah.
Mark Metz.
Yeah. Thank you for the great presentation. Really exciting work. And I have a question related to the notion that it's for the dense and compact areas. This the 15-minute idea. And from Baltic cities, I think Tallinn should be one of the densest ones, but at the same time, it's only like around 500,000 citizens, so it's pretty small. But the question is a bit different. That from my own perspective, so the sort of points of interest or like what I want to see around me is that it's great to have a grocery shop, restaurant. So on nearby, but at the same time, I have a feeling it's great if there is some sort of a hub where most of the city gathers. The thing is not as a city center, but for example, there's this clusters of restaurants and bars and these sorts of areas forming. And the question is that if you have one of these clusters or many, it actually feels like it affects a lot that which kind of people actually mingle together. You have sort of ends up with interesting generational difference. That one group of people are gathering in this sort of cluster of this bars and restaurants, and the other in the other place. So how much do you actually deal with the city also on this level? At a little bit like different question than what you were dealing with, of course, but I wanted to get your comparison as well.
No, thanks a lot. That's very interesting. But I guess, I mean, this is really connected to, I mean, going from paper, which means paper, I mean, published in journals, to the actual ground. We are actually trying to do this. So we have a strong collaboration with the Rome municipality for this. They're looking, I mean, very attentively to what we do, but as you know, I mean, now, I mean, implementing this on the ground is not obvious. It's not obvious at all. Okay. Personally, I don't have a solution for what you just asked, in the sense that I don't know whether, I mean, a cluster or several clusters of hubs could be better than no hubs and small and a myriad of small locations is better. This I don't know, but I suspect that this could be city dependent. Okay, so probably the best solution for a city would not be the same for another city. In this sense, actually, the notion of universality that we like a lot in physics and in general in science, I'm not sure it applies to cities. We still find patterns. Okay. But then when it comes to let's say, sort of optimal or suboptimal solution for a city. I'm not sure, I mean, this universality applies. As for, I mean, this clustering of activity, I guess this could be a very good solution, provided then that this could be easily accessible by the whole basin of attraction of this hub, okay? Because the typical situation now is, okay, there are hubs, okay? And these hubs are typically accessible by cars, by design, actually. Okay, because there are huge parking lots for this. They're typically in the outskirts. And this is actually increasing, I mean, the circulation even in the city center, because people from the city center may want to move to these areas. So, I mean, the point of the proximity and in general optimizing proximity or number of opportunities is not to enclose people, I mean, in cages. You know, there is also been a lot of stories about the 15-minute cities is a sort of plot, I mean, to close people, I mean, in cages, actually. So preventing them to move, I mean, also to other locations, which I guess this is ridiculous. But it's true that actually I may want to stay very, very local, I mean, for very basic things, but then I may want to move, I mean, very, very far to see a Picasso or a big exhibition, right?
Mm. We're actually working on something. There's Jana Sachi, who's not here right now, where we're looking at, with Esteban Moro, at the diversity of people attending museums. And it turns out, like, if you want to be really cool as a museum, you need to attract people from far away in order to get the diversity, because you need to attract sort of like a larger number of people to reach that. And one of the interesting things about this is that you can indeed see what you just described as a caricature in American cities, right? So if you look at the growth of places like Dallas, Houston, or Phoenix, Arizona, where you have these like sort of whole neighborhoods being built with 20,000 people, with a particular type of school, a sports stadium, actual office housing, plus a highway crossing. And people would very rarely actually move out of that neighborhood. And you could totally imagine having a sports stadium for 20,000 people where only Christian rock is played, for example, and they will never hear any other music. And so that kind of stuff is sort of something that looks and sounds sort of like sci-fi utopian or dystopian, but it's very much a reality, because cities at that level are built that way. While if you look at cities like Rome, this is completely unimaginable, because everybody can literally walk anywhere else. And, you know, rich people walk, poor people walk. So everybody has seen a lot of different things. And I find that really interesting, how you analyze Rome with the notion of making it better, having lived in many places and sort of having done courses where we looked at cities globally. I always mention Rome as the example that is sort of like actually quite ideal, because if you know the user manual, you're basically swimming in a sea of points of interest. They're really never ending if your point of interest is not a CAT scanner, which may be rare, right?
Yes, that's true. I mean, about, cultural POIs, there is a lot to say. I guess in general, I'm not sure that attracting people to the few, cultural centers would be the right strategy, okay? There is a whole philosophy, trying to actually attract people also in local areas, in the peripheries, but making, growing, the artistic and the cultural scene also there, okay? Not to prevent you to go to Galleria Borghese, of course, already other big museum, but still, you can have something very, very close. And this would be important also for the social growth of the different environment, because without culture, the environment can actually get very easily degraded, right? Okay, this is not something people take into account when planning cities. So this is one point. So that I'm not sure that the centralization is the only option. The other point is that the actual location of POIs could actually trigger a new generation of recommender systems. Because now again, we have recommender systems in order to go from A to B as fast as possible. Okay, but suppose you can take, 40 minutes in the morning walking, okay, to go to work. But in the meanwhile, you stop at San Luigi de Francesi and look at Caravaggio, okay? So this would actually improve, your work, you improve your quality of life. As you said, Rome, has a huge concentration of POI, especially on the cultural and historical side. But very rarely, citizens can actually appreciate this, except they are tourists or you are, Sunday and you want to take a walk. So while it would be quite interesting to include this somehow in the mesh of the everyday life. Again, you need to push for it. You have to make people aware of this, which is not always obvious now. I never seen, a recommender system or a navigator telling me, look, there's a Caravaggio in the neighborhood. Why don't you stop? It would be nice, right? Okay, I guess someone is thinking about this, but it's not economically viable or convenient. Perhaps it's not the first priority now.
Mike.
Yeah, well, I have several questions. It was very interesting. Thank you so much. One of my questions is basically going maybe into a little bit deeper details of technicalities, because I was sort of playing with both of these tools while you were talking, and I noticed that there are some situations when there are well, I presume it might be mistakes, yes? When you have immediately adjacent hexagonals, which have very different sort of reach times or very different accessibility, basically. But my question is basically how you estimate these times in real life, because you have always this tricky road systems. Sometimes there might be places where you cannot cross the road or something like this. How technically to estimate how much is the time to reach, I don't know, eatery or, I don't know, school from a given place?
You mean in general, not only walking or biking, but any sort of transportation system?
Yeah, for example, walking.
Walking, this is done, we typically use OpenStreetMap, okay? On OpenStreetMap, you have the marking of all the pedestrian paths, okay? So, of course, this would not recommend to cross an highway to go from A to B. So it's really taking care of what could be safe or as safe as possible for a pedestrian. So then we actually use the actual map and the actual paths and the possible multimodal situation. For instance, if you look at the public transportation, that's the reason why, for instance, in many cases in the city center, is the accessibility time. It's smaller for walking than biking, because perhaps in some hallways you cannot get by bike, okay, but you can actually have a sort of shortcut by walking. Okay, so this is taken care in OpenStreetMap. It's not perfect, okay, but the collective operation is improving over time. Another important point is the actual location of the POIs. There are many possible sources of these POIs. For instance, OpenStreetMap is one, Google is another one, but there are other companies also selling data about POIs. They are rarely coinciding, okay? So there is a lot of work in order to make these POIs match. And so all these estimates can be actually biased by a lack of POIs. For instance, even though OpenStreetMap is increasing over time in terms of number of POIs, you never know whether a POI is not there or has not been included in the database. That's why it's also difficult to assess historically the accessibility of cities, because you can go back over time, okay, but you never know whether in the past the database was more incomplete than now, or it was completed and the number of POIs was smaller. But this idea of going back historically in time to the accessibility is very interesting, because personally, I'm very convinced that 50 years ago, cities were already 15 minutes by design, okay?
Mhm.
And then they changed over time, but there is no way to track this unless you go to anecdotal stories, right? Okay, there's no historical data for the POIs. Yes. I don't know whether I totally replied to your question, but technically, yes. So we consider the best we can extract from OpenStreetMap in terms of path.
Okay, okay, well, and I can say that, well, dig a little bit deeper into what you show for Tallinn, and it looks, apparently there are some mistakes, but overall it looks very reasonable.
Okay, I don't know Tallinn at all, so I cannot judge.
Yeah. So that's something, I guess.
But if you send me a message with the mistakes that you see in Tallinn, I can try to understand what's the origin.
Yeah, well, one mistake, actually, well, we are on the topic of mistakes, which I definitely noticed is speaking of sort of city chrome thing and this isochrones. They obviously must be they obviously should satisfy triangle inequality. Yes, getting from A to C should be always not longer than A to B to B to C. And I noticed maybe a couple of places where it is not definitely not the case. I can email you separately, but
Okay.
yes, but it is also probably some sort of fringe cases when one point is in the middle of a park or something like that.
Might be, yes. Might be.
Yes, and but the question, more sort of substantial question I wanted to ask is, what do you think? Is it possible to somehow include the very notion of, I don't know, taxi or car sharing or something like this into the whole picture? It basically seems that it should. When you think of sort of accessibility by car versus accessibility by public transportation, obviously there is some region where you need to use car really, and then it is advantageous to share.
Yeah, this is a very interesting question actually, and of course this is an open ground for this. I know there have been studies, including taxi. Probably you remind me, there was this nice paper by Carlo Ratti and collaborators for Manhattan, in which they estimated how many taxis could be removed from Manhattan if people accept to co-share a taxi by delaying, their trip by, let's say, at most 5 minutes. And actually, they came up with this fantastic estimate that probably you could remove, 70% of the taxi in Manhattan if you would have, taxi sharing. So it would be interesting, to look at this, not only for taxi, but also for collective cars, actually. So people sharing, their paths in a sort of self-organized way. There could be apps, in that direction. But you're right. The idea of having collective transportation system could be included. But I will tell you also more. So in many cities, in particular in, let's say, in the Big South, there are formal transportation systems, so which are public transportation system with timetable and everything. But then there are informal transportation systems. And for instance, we were working with a company in Mexico, because during COVID, they actually tracked, all the informal transportation. Formal transportation means, private citizens with their van or their car, organizing, depending on the needs, little transport, in particular in the outskirts of the city, where the public transport cannot achieve, provide a service. So there is this informal transportation. And they were actually mapping this transportation because this is an essential part of the transportation system in the city. Without this, probably the city would have collapsed. And an interesting point of this, that actually during COVID, the public transportation was shut down, but not the informal transportation. So the informal transportation was actually sustaining the old needs of mobility in Mexico City during COVID. So again, this is not something easily tracked. And again, this makes the one-fit solution even less likely. So one has to go down on the field and try to understand what is the actual situation. But yes, I agree with you. I mean, shared or in general, diverse transportation systems could be very interesting. I remember, for instance, in North Africa, there is a lot of taxi louage. This is something, so shared taxis. This is something already existing since 50 years. Something in Europe, not yet spreading, but we can actually learn from other situations and other experiences.
Okay, I got another question. So basically, we have a situation where we have sort of like the general notion of the city as a complex system. And then now we realize that basically we need personalized medicine because every city is different. There are certain shared things. And I like the fact that you said, like, you don't trust this notion of universality in the sense of physics, which I surmise is similar to say, okay, there's a bunch of air molecules doing the same thing. And if I have a good model, then even if the dynamics is complex, I can have some notion about turbulence or whatever. So one of the interesting things is, like, if we think about like how individual cognitive agents, to put it very broadly, interact with complex systems, then this usually itself is subject to heterogeneity, right? Like all the animals living in a forest, for example, or all the organisms living in a forest have a great variety of different interactions. And if we sort of have a coarse-grained model of that, like the 1960s version of how to do forestry, where, like, trees stand in line and we get rid of all the fungi and like all the birds and bees and whatever, it's probably not the same kind of forest as a classical forest. While at the same time, humans, even without having physics and complexity science, were capable of managing the Amazon rainforest, with like terra preta and stuff like that. That seems to have worked pretty well. So here, this is sort of something which I took from, like, living in Rome again the last 2 summers, and I guess professorship after having studied the city for 3 years, looking at centuries of urban space documentation. One of the things that I sort of like sense that Rome is a city where you have an amazing amount of leeway and variety of like how to use the city. And if you can totally have like what the Romans call miseria. So you can be depressed about like the city being stressful, not giving you the opportunity you need and stuff like that. But if you have the means and you know how to use the city, it is something that is like almost like the optimal instrument to play life, because you can actually sort of like concatenate things which in any other city, you go to the opera and then you would drive somewhere else to go to a restaurant. Well, in Rome, you can sort of like intertwine this, including with, oh, I want to have a casual chat with somebody on the street corner, and you just walk around the right corner and there will be somebody you don't know yet and you can have a chat. And so that kind of stuff is sort of something where I'm almost tempted to hypothesize that we need not just general universal laws of complexity, but sort of user manuals, simple instructions that allow people to sort of perform their own interaction within this complex system. And that would be something which, for example, would be comparable to other complex systems. Like noise induction in social media is a problem which we cannot solve with, fact checking, because the only people who read the fact checks are the fact checkers themselves and, democratic journalists, basically, because even their audience doesn't read that. But if we learn that there is noise induction going on and people are trying to be swayed, but the actual underlying message is always misogyny, xenophobia, homophobia, transphobia, greed, that is sort of something which we can put on a sheet of paper and give everybody. And it's like, okay, if you smell xenophobia, it's probably a rat. So, don't fall for it. Don't do it yourself. And that would probably work out much better than to explain to people, of like how noise induction works, which, you know, broad audience will never get a Langevin equation, right? So this is not like, it's not something people do for fun. And so the question is that something we can actually measure? And looking at many different cities, that's where, you know, sort of like our overviews, like you have shown some really cool examples of like how cities look different and the same. And like, if you look at the same stuff, like how different cities are, need probably different recipes. Like Dallas is a place, I lived there for 7 years. It's really awful if you want to walk. It's really awful if you want to use public transportation. Actually, people use their car to drive to the public transportation parking lot at their destination.
Yes.
Right? Because the public transportation is built not to be used, which is unbelievable if you think about that. But that's like how they've done it. And, you know, everybody parks at, you know, the train station downtown, basically driving from their own train station out of downtown, because it's just not worthwhile using that because it's too unreliable. And I think that is sort of like an interesting thing. How can a place like Dallas nevertheless be awesome? And, you know, you need a user manual, then that is awesome, but is also super bad for the environment, because in this case, you drive a lot. So there, I would say, yeah, you need to change the city. But in a place like Rome, I'm not sure if you share my skepticism, but like, I would be very skeptical about changing Rome because it's not going to get better.
Okay, let me start with a general consideration. So, you know, when you look at this kind of systems, there are two different perspectives. Okay, if you look from the future means I look at the situation right now. Okay, when this situation is already there, you have the impression, and this is probably was the mistake of Hegel, I mean, long ago, that this ending point was the only possible needed ending point for the evolution of this system, right? And if you look at many different cities, I mean, this is what you think. I mean, this is the history went this way. This is the only way in which this could actually be gone. But we know this is not true. I mean, so if you change slightly the initial conditions, the final condition could be arbitrarily different. Probably the reason why we see so many different cities on the planet, of course, I mean, is driven by the local geography and geomorphology. But it could also be driven by the fact that the initial condition in terms of culture, attitude, I mean, all sorts of stuff, climate, drove the system in a different part of the phase space. So in this sense, I don't think, I mean, a system is totally controllable, okay, from the complex point of view, because there are so many parameters to be controlled and we simply can't. Okay, so we typically, and the hope, I mean, as a complex system scientist, is to find, I mean, let's say the relevant parameters in the city, okay? The relevant parameter responsible for the final outcome or the final state in which the city is. So somehow the role of complex system science in cities now should be trying to find these important or relevant parameters, which will be the important rules of the game. Now, how these rules then combine in order to give you the final form of the city, this is hardly controllable, okay? Because this depends on so many other factors you cannot control. I mean, in this sense, that could be some sort of universality in the inner rules, okay, the underlying rules, okay? But then, like in physics, I mean, you can be universal for very different gases, but different gases behave in totally different way, even though actually they actually obey to the same overall rules. So I guess, I mean, cities from this perspective do not make exceptions. That's why when I say, I mean, the diversity of cities could be very interesting because you can try to distill what is common among all these cities and try to identify what are the common parameters. But this is a difficult endeavor actually, because you tend to put together something and perhaps you are overlooking a certain number of parameters, okay, which will make the difference. And then you put together, like say, apples and bananas in this situation. But still, we keep trying doing this. So I guess this could be the role. I mean, so going back to your question, there is something we could measure. Yes, this is what we typically do. For instance, if you look at models for segregation, this is what we're trying to understand. I mean, so what are the basic ingredients leading people to segregation or gentrification? Okay, but again, so the point is, we hope to get to these elements, right? But then once you have a specific city and you want to find a solution in order to improve the city or healing the difficulties and the issues of these cities, I'm not sure that these rules will be really useful. I mean, totally useful, because then you have to somehow get down, I mean, the solution to a situation which is already highly biased. And so that's why I was pushing more for a sort of bottom-up versus top-down feedback loop. And probably this is in terms of digital twins, I think what is really lacking in this situation are people needs. But there is no way in which we can actually guess those needs at the very moment. So when I say needs, I mean, why do you need to move? Where? For which reason? And how often? So what are the other constraints? I mean, this kind of stuff we don't know. We tend to presume, we pretend to presume this data looking at the actual, for instance, trajectories of GPS. These GPS trajectories are basically, they don't say much about the actual intentions of people, why this could be important. So somehow empowering people and involving people in concrete projects can have a side effect of also revealing what could be really real ambition, the real needs in this situation. So to summarize, I mean, I'm not diminishing, I mean, the role of complexity science in this, because this is what we do, I mean, every day. I'm simply not sure that we'll find the ultimate model for cities, like much in the same way in which we have the Ising model for magnetism. I mean, this, I guess, is not possible simply because the complexity of the cities is too high, I mean, for our model to be reproduced. I mean, I make a last example. So, you know, people typically believe now in artificial intelligence able to make forecasts, okay? And, you know, I mean, when you think, for instance, of forecasts, you have to understand what is the complexity of the underlying process, right? Okay, why? Because, I mean, the way in which you look at predictions is the following. You typically look at the past, and you find that the past is a similar situation, which could be similar to the present one. And then the future of that similar situation could be presumably the future of our present situation. This is called the method of the analogous, okay? But in order to do this, you need to find a long enough data set in order to have all possible situations already represented in the past. But this is possible only if the complexity of the system is small enough. For instance, for tides, actually, this method is working perfectly. You can actually predict tides in a very effective way, because, I mean, the complexity of tides is very small. Okay, while if you look at forecast prediction, the system now is so complex that there's no way you can actually look in the past a similar situation, a really similar situation to what you're experiencing now. And so you need to model the system, not only looking at data and try to hope that the data alone will help you in this situation. So again, I mean, the role of complex system scientists would be the one of modeling systems, and then try to apply this model to the present situation. Sorry, long answer for.
No, but this is, thank you very much for lining this out so well. And I think there is, like, actually in what you said, there is a sort of like, you know, the whole contention between humanist inquiry versus complexity science versus physics of culture and social stuff is in there. And I think we could actually drill into this, which would be very, very interesting. So one of the things that you said at the end was this kind of thing that the possibility space is so large. So it's not likely that your situation, even if it looks similar to the past, will be very similar, because there is many situations which never happened in the past. And it's interesting that so far, you know, complexity science has looked at systems where this was more possible than here, right? So, you know, if you think about like all the 100-character sequences of ATCG in the genome, or all the possible foldings of proteins, yeah, these are massive numbers. The same, the combinatorial space of Go or chess is massive. But this is absolutely peanuts against like the space of all possible images and the space of all possible perceptions by 7 billion people of those images. And so that is, I think, sort of something where indeed we encounter this kind of situation where we cannot fully sort of like permutate out. It's not a permutation space. That hypercube is sort of unachievable. But then there is another interesting thing, which, you know, we have made a lot of progress regarding segregation, and these patterns may still be there. Like one of the, I think, cool examples for the audience would be, you know, this model by Michael Macy, you know, following on Schelling, where sort of like the more you're actually tolerant, you move into a diverse neighborhood, but because of the sort of like way this rolls out, you will very likely end up in a house with people that are very similar to you. So there's a house full of Koreans, a house full of Chinese, a house full of German, a house full of Italians. And if you move into the wrong house, you get the real culture shock, basically. And this sort of seems to happen in diverse places. People sort of micro-segregate. And this is a very simple game theoretic consequence, which one can actually do a mathematical model. And for example, in Alston and Boston, you can actually see that. While in other places, and this is now where the interesting thing comes to be, which I sort of like suffered through this for like 15 years until I realized, because somebody else told me what was going on, complexity science, including in culture and social systems, for a very long time were funded to do mathematical models. So people came up to do these mathematical models, and if you didn't have a model, it wasn't considered proper research in complexity science. While in the humanities, quantification was supposed to not work. So because history is always special, which is exactly what we're saying here. But there is something in between, and I think this is similar to astronomy. We need to do quantitative observation because we do find patterns which are non-trivial and they're non-random and they're not always special. And so here, again, segregation. If you look at the racial dot maps for the United States, they've done this for the 2010 census, and I think 8 years later, so where every dot corresponds to one of the ethnicities that is collected in the census, you will actually see that there is certain patterns throughout the US you find all over the place, except Portland, because they never had Black people because they were the center of the KKK. While on the other hand, if you look at Brazil, where the same type of map exists, you showed this picture of Sao Paulo with, you know, the balcony, the famous picture with the balconies, with the pools and the favela on the other side of the fence. So they are as heartbreakingly segregated, but in a completely different way. And if you look at Rome, where there's 50,000 Peruvians, again, the segregation is very, very different from Brazil and the US. But the underlying generating mechanism in all three cases is a generating mechanism. There's a certain way while situations roll out like that, which can be put on a presidential summary in 1 or 2 pages, and they totally are not a force of nature. They're actually a shitty process of humans deciding to be, you know, xenophobic or enforcing inequality and stuff like that. And so the question is, can we create research programs where this quantitative observation is sort of central and actually is supported by modeling, but also supported by qualitative research. And all these three parts actually mutually respect each other. You know, the individual local historian, the quantitative observer, and the mathematical modeler actually know that none of their approaches captures the whole thing. And if you want to have any leeway in understanding, quote unquote, a city, we probably have to throw everything together and sort of like approach it as a sort of larger project.
Do we write an ERC together on this?
Yeah, let's do it.
It seems a very good plan for a project, right? I'm totally with you. I mean, we really need this. Yes, I really need this. Yes, that would be important. This is what I was mentioning. We can probably hope, I mean, to identify the underlying basic mechanism for something. And then depending on the local condition, you can end up in totally different situation. But this doesn't mean that these are different rules. Probably the rules are the same, but of course, I mean, you're not considering all the possible variables and initial condition. Yes, I'm totally with you with this, and I totally agree that this cannot be only an art science project. Actually, has to be mapped also with historians, so with sociologists and anthropologists. Yeah. Probably this, I mean, is one of the most, I mean, in my view, I mean, this is one of the most complex phenomenon, because if you look at epidemic spreading, of course, I mean, this is very complex, right? But there is no cognition, at least that we know, of viruses and bacteria, right? While in this situation, there is cognition of human beings, I mean, taking decisions, and we know, I mean, how it's complicated, I mean, to test, I mean, opinions and the way in which people take decisions. So I guess this is the ultimate goal, because, I mean, people react. I mean, there is a lot of counter feedback loops in this situation. And you cannot pretend to have got, I mean, the whole point unless you take into account also these feedback loops.
Yeah, would you agree that cities are not just like, a mode of living, but a cultural product? And there's, I think, something similar going on, which is really amazing and awesome, which probably is part of the driver why people move to cities. It's like music. There's an infinite amount of opportunity. And the more people live together, the more these opportunities grow. Like if you think about like what's going on in music right now, on the one hand, it becomes more boring because you can reproduce everything with AI. While at the same time, the parameter space becomes more accessible. And I actually just come back from a conference where we talked about this, and there were people like the guy who did the Windows Start sound and whatever. And we all agreed that like at no point in history has there been so much opportunity, and the space of possibility has never been so large in front of us, which at the same time can be intimidating. But also, I mean, this is the most awesome situation. Like it's like there's powder snow in the mountains and you can ski. And so cities are similar, obviously, with the big problem that if you don't do good music, maybe less people will be happy, but it's not like a significant amount of people die. Well, if a city is messed up, like a mega city like Mexico City, there is like 30, 40, 60% of the people who don't have a proper life and will have a very smaller life expectancy. So it's at the same time a cultural product which is sort of enthusiasm inducing in building and performing and making it better, while at the same time there is this really big issue that it needs to be mitigated for people who are not in the right position within these cities.
Yeah, you basically touch, I mean, two main points. I mean, the one is the inequalities, which are growing. I mean, they're growing as much as the diversity is growing in cities in terms of, I mean, diversities of opportunities. But, I mean, I'm very happy, I mean, to discuss about this because, I mean, in my other life, actually, I've been keep investigating actually all these processes of innovation and the way in which people explore, I mean, the space of possibilities. And I've been always wondering whether, I mean, it's better to have, I mean, a lot of people in the same place or many different people, I mean, isolated in different small places in order to have a largest variety. I mean, I don't have a solution, but I mean, if you look at the reality, I mean, and you look at the number of papers, scientific papers, the number of patents produced in cities with respect to something produced in small areas, this is no comparison at all. So presumably, I mean, the concentration makes, I mean, the diversity so high that then sampling this diversity can actually lead to, I mean, breakthroughs in many different directions. More than, because you can always think, I mean, a small place could actually be hosting, I mean, weird people, right? I mean, people, I mean, off the Gaussian, I mean, in the tail of the distribution. But also in big concentrations, actually, you have this. And so perhaps cities have also probably are better equipped in order to keep track of these interesting deviations. Of course, there are also the bad deviations, right? But the interesting deviations are there.
That's, by the way, why we're all in Tallinn. We can be weird here. But
Yes.
there is no hands up. I nudge you to answer this connection between these two. So you also do sort of research and innovation, you know, the adjacent possible, stuff like that.
Yes.
How do you think these two things go together? Like there's probably a nexus, as you said, you know, city 10 times as large, 12 times as many patents. So is the city both nurturing this process while at the same time probably also being a problem? Because then people only come up with the same stuff, or like, how do we?
Actually, so we are trying to model this, and the point is how to model the expansion of the adjacent possible at the collective level. Because at the individual level, I mean, we did this already, okay, and the predictions are quite clear. Now, when you look at the collective level, it's not obvious. I mean, what is the situation? So we are all somehow drawing things from a common pool, or we are actually exploring the same adjacent possible, or each of us has his own adjacent possible, and then for some reason when I discuss with you, I also expand mine based on the experience and interaction with you. So this is still on the way, actually. We don't have a final answer, but the first indication is actually that there is a multiplicative process in terms of diversity out of this interaction. So that could be one of the reasons why cities are so prolific in terms of innovation in general, so whether it is the paper patents or style of life, music, so whatever you can mention also from the cultural point of view. But yeah, I guess it would be an interesting direction. It is actually an interesting direction to look at these collective innovation processes.
We got 12 more minutes. Any questions from the audience? No? Yes.
Or we go for a drink earlier.
But we can do that too. That's true. No, you don't give up on your question.
Please.
You guys were just, thank you for your talk, by the way. As you guys were talking, I was just thinking, well, I do know that you have.
Sorry, I cannot hear very well.
Can you walk up to this?
Yeah, sure. So as you guys were talking, I couldn't help but think there is this, the big complexity that comes with the collective that lives in the city also means the conflict of interest. And a lot of times when you're trying to make sense of, let's say, mobility or anything else, I find it quite hard trying to map out whose side of the story we're looking at, really. So what do you try to look at, objectively speaking, not maybe just mobility, but in general, as someone who thinks about cities a lot, how do you try to make sense of all these different stakeholders that are involved, maybe?
Oh my God, that's tough. You know, I mean, the reason why we called our platform What If Platform is because, I mean, we are trying not to have decision theaters. You know, decision theaters are supposed to be these places in which you go there, you look at the data, you run a few simulations and scenarios, and then you have the final solution, which could be the good solution to be implemented, right? I guess, I mean, from the possibility in terms of a good scenario and the actual implementation, there is all the politics in the good sense, actually. I mean, not the politics of interest, but the politics in the sense I decide what are the priorities. So what should be optimized is not something I can decide. I mean, of course, I mean, I can have my own perspective, but I'm pretty sure, I mean, that some politician may want to have segregated people, okay? Some may want to reduce, I mean, inequalities, okay? In some cases, they may want the car industry to thrive also in cities, you know? So we have good examples, I mean, on the planet of totally conflicting views on even climate change or vaccines, you know, and more there is polarization on this. So I wouldn't say out of all the studies, there could be an optimal solution like we used to be in engineering sciences, for instance. So there is no optimal solution. The optimal solution would be somehow the putting together, I mean, a possible scenario, okay, with a possible policy or aims, I mean, for implementing a specific policy. So, and I guess that's the reason why we see so much diversity also from very similar cities, actually. Because I mean, cities in Europe are not very different after all, okay, in terms of culture, also geography in many cases. But still, if you go there, I mean, so the mayor and the municipality, I mean, it's having very important role, I mean, in shaping the way in which the cities are. So I guess, I mean, I don't have a general solution. I guess a general solution cannot come from these modeling schemes. So the modeling schemes can give you a framework to take more informed decisions, but then it's actually up to decision makers, I mean, to put their grain of salt, hopefully.
I'd like to add a point, which is great. You put the evidence on the screen. I thank you very much for putting this Invisible Cities book cover by Italo Calvino up. Yeah. Particularly because there's this picture, which is probably, I don't know, I can't date it precisely, but I would probably say it's like 1580 or something, which shows the apparatus with which you draw a panorama of a city. Yes. Which was sort of like the equivalent of a satellite picture or an aerial picture. And what you can see there is actually exactly describing our situation right now. So you need a point of view, which is literally this little point in the middle, where you fix your eyeball. So you have a viewing cone that's stabilized on your drawing plane, which is this lattice. And then you can actually sort of like draw the city as a whole. So you do this mathematical modeling, and actually, you know, the invariants we have in network science and so on and mathematical models are very much exactly that. They're like projections. You calculate eigenvectors and matrices, or you have a vanishing point in central perspective that is very much familiar and sort of like, you know, related to each other. And there you do something which not everybody can do, because not everybody has the apparatus, not everybody has learned how to do it, not everybody has access to the garden of the Vatican from which you have this nice view or whatever. And then you produce something which can be used by everybody. And everybody will see this panorama in a completely different way. So the bishop will identify, okay, how many rich people live there who have a little tower on their house, and how rich are they, and who do they belong to? Somebody else will say, oh, I cannot really easily conquer this city because the murals are strong. Somebody else will say, oh, interesting, I see so many houses, I could sell so much grain, or something like that. So people have very different reactions to this kind of thing. And in some sense, what we do, our analysis, even if we do stupid human mobility analysis of people going from birth to death or moving from cell phone tower to cell phone tower, that can be, if we're lucky, it will be used by as many people as these maps from the 16th century. And I think that is sort of something which makes me very enthusiastic, because I'm always surprised what people do with this kind of stuff, because it's totally 90% of the time stuff I never thought about, for example.
And interesting, I mean, thanks for pointing it out, actually. I never realized, I mean, that this picture, I mean, so never thought of this picture, I mean, the way in which you described it. So basically, if you change the point, okay, from which you project, you might have a totally different city, but also you can probably think about the philosophy or the policy behind as a sort of screens put in front of the projector, right? Okay, so
yeah.
So it's very prolific as an image. Thanks a lot. I guess there is a question from Mike.
Yes, Mike.
Yeah,
last question.
I wanted to, it is sort of part question, part remark, sort of seconding the question before that, because I was thinking that basically it is not always, you say it in a way like it is a question for politicians to decide one way or another how to arrange things, but it is not always, city is not a top-down thing. People behave according to their local incentives. For example, people who own a restaurant might not be interested in in the amount of time it takes to their customers to reach the restaurant, but they are more interested in their own sort of profits, which are maybe dependent on being located in a place where large flows are, or being located in a place where high density is. So, I mean, it is not obvious. So it is interesting to see this sort of what-if scenarios, but sometimes it is not at all clear what exactly are the political incentives one should put to realize. But I mean, it is probably a trivial comment, but just I wanted to make it.
No, but I'm totally
to
with you.
point out that.
I'm totally with you with this. I mean, it's not clear at all. I mean, how to go from this what-if scenarios to a more concrete implementation. I agree with you. I mean, that sometimes also the kind of incentives or kind of actions, I mean, politicians or policymakers do, I mean, are not clear at all. I mean, so are not revealing any global structure or global idea they have in mind. Sometimes they are just made because they have the opportunity to do so, because there is budget for this, and they found, I mean, a reasonable way to implement the solution, and they go for it. So in this sense, I mean, cities could be like animals in which there are several actors, I mean, doing things, but then the global evolution is like a biological evolution. I mean, something, I mean, can actually work, some cannot work. Still, I mean, the city is there, is growing in some way. So the diversity could also come from this sort of unpredictable set of interventions, right? I mean, not, and actually, I don't believe in blueprints for cities. I mean, there are blueprints, engineers are doing this all the time, but I don't think that they are actually implemented.
There's a really cool example in Rome where Rodolfo Lanciani, who wrote the last Codex Vaticanus Latinus, actually with a ballpoint pen, he walked around Rome when all the real estate speculation was going on around 1900, and he would draw down all the ruins he would see in the pits where they sort of like opened the door, and then he put them together in this codex, and then he did a new forma urbis, like a new city map based on that. And in detail, the city map is completely wrong at any point. But if you zoom out, it looks correct. So everybody accepts this as the best city map of like ancient ruins, while at the same time, it's always wrong, because exactly as you say, there is no such way as a blueprint. Even if you would have the Roman original idea, obviously it was implemented in a completely different way. I'd like to thank you very much. We reached the 2-hour mark. There's one housekeeping thing that I need to do, which is next week, we have another Open Lab seminar, and I hope everybody comes back and more people will join. For Mariah Meyer. Mariah Meyer was an information visualizer designer at the Broad Institute, and then changed to the University of Utah, did a very similar move than myself. She moved to Sweden, I moved to Estonia from Texas. And her talk will be about troubling visualization, which is ironically very much related to what we just talked about, because visualization, information visualization, is supposed to be monosemic. So if you look at a scholarly figure, everything should mean one thing, because that's the whole point about like doing a figure. But there is a troubling aspect. Different people perceive things in different ways. Like if you look at a map, if you look at a panorama, if you look at a scatter plot, you may see completely different things. That's the troubling part. Trouble is this kind of troubling word comes out of the gender theory, which is very qualitative, as you know. So the combination of sort of like visualization with that in a practical sense and manner is sort of something that we consider supremely interesting. So this will happen next week, but today let's thank Vittorio Loreto, and he also has thanks. Let me make this a little larger here. What you're saying with this final slide is it takes a village, which is very much my message and our message too. So there's never just one person, and nevertheless, we thank you a lot for bringing this all together and making the village happen. So thank you very much, and I love to talk in the future, and let's do that ERC, yes.
Yes, Max, I mean, thanks a lot again. Thanks to all of you. And of course, I mean, if you see overlaps, contacts with what I just said, I mean, in your own activity and research, let me know. I mean, drop me a message, and I'll be pleased to start interacting. Yes, and let's plan for an ERC on this.
Okay, nice.
Thanks a lot.
Bye-bye.
Bye-bye. Bye-bye.
Okay.